from the project, from me, please, I will share a link at the end, how you can reach to us, how you can join the project, how you can collaborate with us, and also part of the open source program office at Sourcelabs. So thanks to that, I'm being able to contribute most of my time to open source, working the Selenium project. And if you want to reach out to me, I mean, that's my Twitter account. I have my messages open. If you are shy and you don't want to post anything, then you can ask me directly over there, and I will do my best to help you. So what are we going to be talking today? I want to cover the topic of Selenium Grid from the beginning, which is talking about testing infrastructure. Why do we need a testing infrastructure? What is Selenium Grid? And then after clearing that part out, I'm going to jump to show you what's the overview, how it works, the new grid, and then maybe have a few demos showing how the grid could work locally and in the cloud. And then I'm going to share an experiment at the end. So hopefully I will do a few slides, and then it will be mostly demos. And then let's see how this goes. Hopefully some of you are already familiar with what Selenium and Grid is, but nevertheless, let's talk about it. So starting with the testing infrastructure topic, sometimes people, when they're starting into the test automation world, they wonder, why do we need one? Why can't I run everything on my laptop, right? Why can't I use my phone to test everything? And one of the main situations we have here is that when you develop an application or when you run a test on your laptop or on your phone, we are being ambiguous, because obviously in our laptop we have several applications installed, we have dependencies installed. In my phone, maybe I have a good internet connection, or I have a given operating system installed. So all these things are biasing your environment. So when we have a testing infrastructure, well, there is a benefit that there is like a plain there is a clean slate for everyone to run and run their tests, for their applications. And one of the key things is that obviously nowadays we want to do fast iterations, develop software faster. And if you have an infrastructure that allows you to run tests, many of them at the same time, that will speed up the software development lifecycle. And complementing that, when you have a wide range of browsers, devices, operating systems where you can test, that gives you confidence, because obviously your users are not, they are not using always your same operating system, the same browser you're using. So it's very, very diverse, right? Obviously, you can reduce the amount of browsers, devices, and operating systems if you have things like Google Analytics that could check what are your users using when they use your app or when they visit your website. But in general, if you have a more coverage, you have a better sense of tranquility. So, quick recap of the software development lifecycle. Normally, nowadays, we have development teams that have roles of development, product management, testing. Sometimes those roles are interchangeable, but in general, we work in a way that we define what we want to work on, and then we write some tests at different levels. At some point, we build our code, right? We want to run some tests. After that, build is being done. And then when things are coming together, when we have more than one component, then we start testing all things together. When things go well, we do deployments. We have smoke tests in those environments to see that everything's still fine. And we can, go higher in different types of testing. And in the end, If things go well, we deploy to production, but still we can do testing in production, we can monitor and do many things, right? So normally we follow these steps. The key thing is that the more to the left you are, the faster feedback you need. That's why if you have a stable build and you can verify the functionality, hopefully you already checked many things before. But for all of this, it's super important to have an infrastructure that allows you to do builds and to do testing. So that's why a testing infrastructure is important, because it enables you to be faster in the software development lifecycle. So to summarize this, you want to be faster, you want to be able to shift either to the left or to the right, it doesn't matter. Both answers are good. It just depends on your environment and on your needs. And in the end, what you want is confidence, right? You want to be able to test in different combinations. You want to be more confident. You want to be able to test in devices and browsers that are almost or the same one that your customer, your user is using. So let's jump to Selenium Grid. So what is Selenium Grid and why do we need it? Selenium Grid allows us to execute WebDriver tests on remote machines. So this goes back to the topic of avoiding the use case or the situation where it runs on my machine. So this test works on my machine because I have Safari installed, but if my colleague has a Windows machine, they cannot run the test against Safari. And it happens that our customers mostly use Safari, for example. So in this case, if we have a central place where many browsers are available, like Chrome, Firefox, Safari, Edge, then we can run these tests over there. The grid simply routes command. So you, from the client, you send the command to the grid, and based on that, it will be sent to the correct browser where the application is running. In general, it's allowing you to run many tests in parallel on multiple machines. And with that, you will get faster results, which will improve your iteration speed. And then going back to what I was saying before, here you can have more browser versions, more configurations, everything in a central point. It's super important to realize that grid is just one option out there. Like you could also maybe have CI systems where you have 100 tests and you have ways to break them into chunks of 20, and you run 20 tests on every single build, and you run those tests locally. So grid is just a way to parallelize tests, but it's not the only one. It's made to solve general problems about delegation and environments, but it will, for example, not manage your infrastructure. You still have to install the browsers, you still have to keep them updated, you still need to have the operating system up to date, and so on. Okay, so that was the theory part. Now let's jump slowly into a more practical part. Let's jump into Grid 4. I didn't mention this before, but I mean, if you have questions, maybe you can write them in the chat and I will have a look at them at the end. But then basically, please be active and drop your questions there in case there are some doubts. So let's start on this. Grid 4, you may think like, why there is a Grid 4? Yeah, because there was a Grid 3, and this Grid 4 is completely new. It was written from scratch. So I'm going to share why it was done like that. I'm going to share the architecture, and we're going to jump into a demo right away. So Grid 3 was a very sophisticated piece of code. If you had the opportunity to read the code, was doing a lot of, it was also Java code. It was full of inheritance, extensions, way to override behaviors. So it was very sophisticated, very smart, well done. But there was a problem that only a few people were able to do that. Only a few people were able to maintain it and understand how it worked. So when bug reports were coming, it was extremely hard. And you could say that 90% of the users were not actually taking benefit of all the features that that complexity was bringing. Also, what was happening is that in the code base, we had two servers in one single binary. So the traditional hub node that we will explain it in a moment, and the standalone were two different code paths living in the same one. So that was bringing the situation where a user could report a bug saying, it's happening in the standalone mode, but it doesn't work in the hub and node mode. So I'm super confused. Well, the confusion was because it was basically two different code bases. But the new one, it's a unified and smart code base because we do better routing internally. And I will show you in a moment what that means. And from the start, there are more people who understand how it works, and there are more people contributing to it. And together with that, the new grid has is taking advantage of the modern infrastructure. So for example, you can use Docker containers out of the box. And we have distributed tracing tools. So you could see like how long each request takes, and it could help you to find issues with slowness or where things are getting blocked. So this is a brand new grid. And the important thing is that we're not ignoring the past. So we're writing this new grid, or we wrote this new grid, because we have learned so much from the previous one and from all the workshops we have done, from all the GitHub issues we have received. But the good thing is that we still have the same modes as before. So you have the standalone mode, which is a grid of one. It's useful for local testing or for small test suites. Then you have your laptop, you have your CI/CD, for example, and then you have one single server where all the browsers are registered. You also have the hub and node, which is the typical one you were using in Grid 3. And this is, you have a server, which is the main entry point. In this case, is the hub. And you could have one or many other nodes. And for example, you could have a node that has Windows. You could have another node that has Linux, and etc. And the good thing is that many people who want to move from Grid 3 to Grid 4, well, they need to change a small thing in the scripts to start up the grid. But in general, the structure and the way it's used and the way it works, it's the same one. The interesting thing comes now, because what we did was to break what the hub was before into many little pieces. So the hub was taking care of routing requests. The hub was taking care of having a queue where the new requests were sitting. The hub was taking care of distributing all the requests into the proper nodes. And then the hub was taking care of understanding which session was being executed on each node, right? So we took the time to break all those logical pieces into different components, and that allows you to basically scale up the grid a lot, because you can deploy each one of these components separately, and then you can put it in the cloud, you can put it in different places, and you can give different amount of CPU and RAM to each component. And that's why you could have a better performance grid. So let me show you how the new grid is smarter in the sense of routing, for example. Let's see how a new node is registered to the grid. the first step is that a node will send a message through the event bus. So the new grid has the possibility to send and receive messages through an event bus, or to send and receive information via HTTP requests. So normally the internal communication is done via the event bus, and the rest is done via HTTP requests. In some cases, we use internally HTTP requests because we need them to happen right away. But whenever it's possible, we use the event bus to lighten the internal traffic. So the node sends a message, the event bus publishes it, and the distributor listens to that message saying, okay, there is a new node, and I need to register it. So I will double check that this node actually exists. So it does a HTTP request asking, hey, are you actually there? Then the node acknowledges that, register it, done. This is one of the nice parts of the new grid, the new session. You as a client could send a new session request asking for a session in Safari or in Microsoft Edge, for example. So the router will put that request into the queue. When that happens, then the distributor will be asking the queue every 2 seconds by default, or every second by default, if there is something new to be processed. Then the request will be processed by the distributor, and it will start checking along all the nodes. It will start checking, okay, which node has Safari? Where can I serve this session? It will find the node, and after that, it will say, hey, session map, there is a new session with this ID, and this session is running in this node. So the relationship between the session ID and the node ID is stored in the map, because in the next step, I'm going to show you that when the session starts already, and then the next command will be, for example, load a website, then the client will send the command, the router will check first. Okay, this command is for a session that already exists. So it will ask the session map, where is this session running? The session map will return the node ID, and therefore the router will redirect the request right away to the node. And with that, we're avoiding touching many, many other components in the grid. And with this, it's making the grid a bit smarter, and the routing is much better than before. It also works with Appium. You could have a node that registers normally, right? So we have a normal node with browsers. But the problem with Appium is that Appium doesn't send messages through a bus. So we implemented something that we call a relay node. And the relay node is only taking care of relaying messages back and forth. In this case, we're going to have an Appium server, and then I'm going to demo this in a moment so you can get a better idea of that. The cool thing is that when you configure Grid for Appium, for example, you have to specify things like here you can say, hey, the EXO server is on this location. If you want to check the status endpoint, this is the status endpoint, and the configuration that this server that is living on this address will support is this one. So this is what we call a stereotype. So in this case, maybe an Appium server will support Chrome, Android, and in this platform version. So without going further, let's do a demo to make things more interesting. This will be kind of an extended demo. I will do it live, and it will be, I think, slow paced because I need to understand what I'm doing. Cool. So let's move to the terminal. Here I have the Selenium server jar. So what I want to walk with you, I want to check how everything works. So we're going to start the Selenium server 4. First of all, if you execute this line like this, you will get an extensive and detailed help command, so you can actually understand what component is doing what. But that's not that much different from Grid 3. So let's start the standalone server, and let's understand the log first. As I said, there is OpenTelemetry working out of the box. So if you have a Jaeger server, you can actually connect it to the Grid. But I didn't prepare that part. So let's go with the next line. The Grid is doing the following things. It's detecting how many processors the machine has. And with that, it can actually give a pre-configuration, a recommended configuration to the user. In this case, it will tell us that it discovered 6 drivers. So it discovered 6 browsers. And it discovered Chrome. And it will say that normally you need 1 CPU per Chrome browser. So you can have up to 12 Chrome browsers running at the same time. Same story for Firefox, Edge, Opera. For Safari, you only have 1, because by design, Apple only allows Safari to be executed once per machine. And it's the same story for Safari Technology Preview. Right, so if we go actually to this URL or to localhost 4444, then we will see how the Grid looks like. Let me just a moment. I want to open this here. So if we go here, we can see how the new Grid looks like, right? This is the new UI. Looks a bit nicer than the one we had a few years ago. And then in short, it tells you what platform you're using, the browser, and how many slots you have per browser. So you also have this tab for the sessions, but we don't have any sessions running right now. And yeah, I mean, the typical thing for help. So let's run a few tests and see how things go. I have here a few sample tests. I'm just going to make this bigger. I'm going to hide this because we don't need it. And this is an IP that I don't need right now. I'm going to run everything localhost. And I'm going to change this to Mac because I'm running things on my Mac for now. So what we're going to do, we're going to run a few tests that are very simple. I'm going to create the driver here. This is nothing spectacular. So I'm just going to show you briefly what the tests are, which is not really a test. I mean, we're going to load a website. We're going to do sleeps so you can actually see what is going on. And then we have a few examples with sourcedemo.com, which is the website we use for demos at Sourcelabs. We don't have one for the Selenium project yet, so that's why I'm using this one. So they are tests that are logging in and basically just doing something like putting something in the cart and asserting something, nothing really spectacular. So for purpose of not spending a lot of time in this demo, I'm just going to run this one, and the other ones I will run them in the next demos. So let's run this one, and I'm going to switch right away to the UI, which is not this one. I'm sorry, this is this one, so you can see how sessions are starting to happen. And the browsers are opening, obviously, in a different screen, but you can see how the sessions are starting to be populated in the UI. You can have different information, like the concurrency here. You can also see all the information in the capabilities, right? You can see what browser version is being used, different information about the platform, etc., etc. So this is very straightforward, how the grid is working. But yeah, to be honest, it's a major improvement from the UI we had before. So this is a bit plain right now because we are not seeing all the features from the grid 4, but that's what we're going to do in a moment when these tests are done. In the meantime, when this ends, I will start. I'm just going to jump to the next demo. I mean, I just explained you how the grid looks like. If we check the log, obviously we can see how sessions are being created, how sessions are being closed, which is, I mean, looking at the log is not really spectacular, right? So I'm just going to go to IntelliJ, check that everything finished, and then I'm going to go back to the terminal to stop this server and to clean this log, because what I want to show you is how this new grid works with Docker. So let's jump to this other machine I have. I have a Windows machine running here. And first of all, I'm going to start, we're going to run the containers that we have in this project, the Docker Selenium project. So everything that I'm running here, it's completely documented, and the examples I'm running, these Docker Compose files are here in this repository, so you are free to have a look and check them and play with them on your own. And let's start with them. So the first one I'm going to check with you is this Docker Compose that basically will, let me try if I can see. Okay, so this Docker Compose file will, let me see if I can make this bigger. Okay, that worked. No, it didn't work. We're going to have one hub and 3 nodes, one for Firefox, one for Edge, and one for Chrome. So let's start this. Sorry, I'm just going to copy the command. We're going to use Docker Compose, the name of the file, and app. So this is going to start the grid. And while that happens, I'm going to jump to my browser here. Let me organize these windows. I'm going to jump to this browser here. I'm sorry, I lost this one. Okay, here I am. Great. So, 1 second, please. I'm just going to organize the window. Oh, okay. So this is the window I was looking for. Okay, sorry. Live demos, right? So let's check the grid, how it looks like. So this is the grid in Docker. As I mentioned before, we have a hub and we have 3 nodes. We have a node that is with Microsoft Edge in Linux. Right now, Microsoft Edge in Linux is in beta. So be aware of that. One with Chrome and one with Firefox. The default is that we're going to have only 1 session, but the cool thing will happen in a moment. So let's run some tests. Let's go to IntelliJ. Let's hide this, and let's use the IP of my local machine. And for the sake of time, because I only have 3 slots available, I'm just going to run the same tests for a moment. And then when I have more capacity to run all tests, then I will run them all. So here it is. We will see in a moment how we can see that the queue is already 3 tests. And we will see in a moment when the session, okay. I know why this is not working. Because we don't have a Mac in Docker. We have Linux machines. So we need to ask for a browser that is running in Linux. So let's run this again. And let's go here. The queue will increase to 6, obviously. Well, it didn't, but you can see that the concurrency is already up to 100. And we have 3 sessions. And things start to get nicer when we use Docker because we see this icon here that will show us the live session. The password is the word secret. So even if you're using Docker, you can see how the session looks like, and you can actually interact with the browser. You can resize it, you can play with it. So this brings you the possibility of using this open source tool to run tests locally in your infrastructure and have a first-class debugging experience with it. But one of the things that sometimes is nice about the grid is that, okay, I can debug it, I can interact with the test through this live view, but maybe sometimes I need a video, right? So how do we make that work? If we go back to continue with the demo, here in the Docker Selenium repository, I'm just going to scroll for a moment. We have this section called Dynamic Grid. Sorry, what happened there? So for the ones who have used projects like Selenium, where you were able to run a test against a single Docker container and then several containers were created in the back, this is how this one works. And I will do a demo of that in just a moment. First, we're going to stop the running grid. We're going to leave things clean. And then we're going to use this other Docker Compose file. We're going to use a hub and we're going to use a node. And this is called the Docker node. And the Docker node uses configuration of volumes. So we're going to store all the assets. So this is the video that we're going to create and the capabilities for the session in this directory. And we're going to use a configuration that is declared here in this file. And the configuration from this file is going to tell us what stereotypes the grid is going to support. In this case, we're saying that we're going to use Firefox on Linux, and the Docker image that will support that configuration is this one, Selenium standalone Firefox 4.0.0, so on. Same story for Chrome and same story for Microsoft Edge. Something important is that we communicate with Docker from inside the container through the, I mean, we have to talk with the Docker instance that is living on the host. So that's why we configure this. So as you can see in the comments, is well documented. And also here we can see that there is this video image. So this video image is a container that starts and basically records the test. So how does that work? We are going to start this Docker stack. That was the wrong window. Let's Let's copy and paste this comment. And then this will start the dynamic grid. You can see in the logs that images were pulled, but obviously I was pulling them before, so things are already working. If I go to the grid, we're going to see a single node, but since the machine that I'm using has 12 processors, then it identifies that, okay, you can have up to 12 sessions. So let's run some tests. So let's go to IntelliJ and let's run them all. Before starting, something that is important is that we need to send a few more capabilities to the dynamic grid to record video and a few more things. So for example, we have to add these things. We have to add these capabilities. And let me explain to you. You can add metadata to your tests, and I will show you in a moment what that means. You can say, what's the test name? You need to say, okay, I want to record video. You can also specify a screen resolution and a time zone. I can explain more things, but then we can just start running the tests. I'm gonna switch to the grid. We are gonna see how there is a queue of 15 tests and how the sessions will start getting created. While this happens, I can show you here in the machine I'm running, I can show you the Docker UI. And you can see how containers are created in the background. Like if I scroll down, containers are getting created. And for example, one container is for the browser, the other container is for the video recording, and things are happening right there. So if I go back to the UI, same features like video recording and so on, they're still working. So if I click here, obviously I will be able to see okay, this session already ended, so I couldn't see that. But the same type of features are working. So this is the benefit of having a grid that is dynamic, that grows and shrinks on demand. So I can just send a bunch of requests and have them working based on the amount of CPU and memory that I have in that machine. But I was talking about video, right? So let's go back to the machine where I have this running. And let's look at the directory. So let's go to Docker Selenium. And I have this assets directory. So as you can see, all these files were created a moment ago. And then let's open the first one. We have this file, which is called the session capabilities file. And then let's open it with, I don't know, with Visual Studio Code. And we can see that the capabilities of the session are stored here. And here, this is the se.name file, capability. And this is metadata that you can add to your test. So eventually you can put all this data together and build a dashboard. The other thing that's interesting is the video, obviously. So you can see the video of the test. And it just records what needs to be recorded, right? Like from the beginning to the end of the test gets recorded and it's available for you. If we go back to other, I mean, all of them are basically the same. Cool. So I also have a video of how it works for Appium. So maybe I will share this briefly because the idea is the same one. So this is the video I presented in the Appium conference. So you could see the configuration here, how the relay URL is done, but we went over this a moment ago. So I'm just gonna forward how this looks in the UI. So I'm gonna have the Appium server here. The Appium server is started. I start the grid, and then we can see how the relay configuration is received. So you see that we have a device for Android, and we have a device for iOS with Safari available. So then what we can do now is actually to run a test. So it works the same way, either with native apps or with mobile browsers. It works in the same way. So we're going to run some tests, and you can see how the grid reacts in the same way, because it is just like relaying commands to the Appium server, and then to the emulators and simulators. So I'm just gonna, so here is the demo for the Android browser, which works in the same way as we did a moment ago. And I'm just gonna forward, so because it's just the same thing we saw a moment ago, but with Appium. Right. Cool. So this is the first part of the demo. And I see that I only have 10 minutes left. Like, is it a problem if we run by like maybe 5 or 10 minutes more, Costas?
No, I think it's okay.
Okay, cool. Then thank you. So let's go back to the slides for a moment. If I find them, here they are. So the next thing is that I wanted to share with you is one of the things that was a feature in Selenium and many people use, which is how can I combine my local grid and the cloud? In this case, maybe I have a good machine that can run a few Linux tests, so with browsers running on Linux. And then how maybe can I combine that with a cloud like Sourcelabs? So we can use the same feature, the relay node, and we could add it to the dynamic grid and actually have things working, running a few tests locally and running the other ones in Sourcelabs. So the purpose here is to show how this works. I will need to regenerate my API key at Sourcelabs, but that's okay. So just let me copy the configuration for relay for a moment. And then let me go, here. So the first thing we're gonna do is to stop this, because we need to amend the configuration. So here we can add an extra configuration saying this is the configuration for the relay. And yes, my API key is there, but I will renew it in a moment. But then I will say that you can have Safari, you can have macOS, and you can have the browser version, which is 14. We're going to see how this looks in a moment. So let's start the grid again. And let's go to the UI. I mean, right now the UI is not up because the grid is done, but here it is again. And we can see that we have a node that is supporting, you see, Chrome in Linux, Firefox in Linux, and then you have here Mac in Safari and Mac. Right, so what can we do now? Now we can run tests in Linux and Mac in the cloud. So how do we do that? Let's go back to our tests. And obviously we need to add to our data provider, we need to add a new browser, which is, we're gonna use Safari. And here, we're gonna use something, we're gonna also modify this so we can do capabilities equals new Safari options, and then we do a break. Something that would be nice to have is, I think I have the if around here. No, I don't have around the, no, I don't have it. So let's do this. If I'm gonna run a test in the cloud, which is with Safari, then let's change the capabilities. And for everything else, we can leave it as it is. So in this case, we can do something like, something simple, like telling Sourcelabs, this is a test name, right? So let's run this. What we're gonna do, we're gonna run tests locally, and the tests that we cannot run locally, like the Safari ones, we're gonna run them in the cloud. If you remember, the grid is running on a Windows machine. So that's why I'm doing all this combination. I'm gonna run this. And then I'm gonna go back to the UI. Where is the UI? Here is the UI. And you can see how the tests are starting to run. And at the same time, there are the tests. So we have one in the cloud running. And what I'm gonna do in a new tab is to actually go to Sourcelabs and log in. So what happens is that I'm running both locally and in the cloud a few tests. So here are the tests that are being forwarded from my local grid. And at the same time, I'm running tests. So the mix of the cloud and my local grid is already happening here. And obviously I can have videos from these tests locally, and I can have the videos I have in the cloud by executing the tests that I normally run in SOS. So it's like the balance between what can I do locally and what can I use in the cloud. So you can think about this like I can run some mobile tests in the cloud, plus some Linux tests locally, and so on. So that's the overall idea of connecting your local grid with the cloud. Yeah, I mean, this is already working. I'm not gonna wait until everything ends. Okay, so success, all our tests run successfully, locally and in the cloud. So what is next? Let's go back to the slides. With the thing that we just saw, combining the cloud and combining the local grid, one idea we had at SOS is that, okay, maybe there is a way that people can run tests locally, but still have all the videos, the logs, and have all the benefit from Sourcelabs, even though they're running tests locally. So there is this experiment I've been working on that is called SOS to go. And what I want to do now is show you how it works, so you get an idea of if this is a good thing to use or not. And maybe you can give me feedback about that. So SOS to go is something that allows you to run tests on your infrastructure, but you can see the results in Sourcelabs. So you can run all the tests in Chrome, Firefox, and Edge on Linux. And then you will get the screenshots, the videos, the logs, everything in the dashboard at Sourcelabs. Then you can use all the insights analytics from Sourcelabs. But then you can see all your tests in one single place, that is Sourcelabs. Right. So we're going to have a look at this in a moment. But the idea of this is that when you are able to push all your tests to a single place, you have lots of data to combine. So maybe you can actually run your mobile tests, your browser tests, and eventually your visual tests in Sourcelabs. You can do all this, and this is a mash of things that you can have to get more insights from your tests. So how does it work? You have your network, where you're running your tests, where your application under test lives. You have a grid that is running, and you have your client, your laptop, or your CI/CD. Then you run your test, and you're testing your application under test that lives inside your domain. And then you have Sourcelabs on the other side. What happens is that we have a little container that will be activated when the test finishes. It will take the video, the screenshots, and the logs. They will be uploaded to Sourcelabs, and then you will be able to see everything in a single place. Let's have a look. And this is the last demo of today. The first thing I want to do is to go to the website. So you have full instructions here, how to get started. Obviously, you need a Sourcelabs username and an access key, but it's well documented here how to get started and how to do things. We also have a demo here in video. And in general, what you do is you have the same structure that we were checking a moment ago for the dynamic grid with different Docker images. And then we have an extra container that is taking care of uploading the files to Sourcelabs. So everything here is clear. This is how you start a container. And then we're going to check how the test needs to look like so things run properly. First, so this is the config.toml that we were checking a moment ago. So first, let's run this. Here we have it. And I'm just going to check that everything is there. So let's start this. Okay, so something is running there. Maybe I didn't stop the grid here. Okay, I didn't stop the grid. So let's clean this. And now let's run this again. It looks very similar because obviously it's an extension of the open source Selenium Grid. And if we have a look, here it is. It looks very, very similar, right? So now let's go to our tests. Here I have a different class for them. To be more specific, what we need to do here is to add some Sourcelabs capabilities, which is basically which data center we want to upload the tests, because we have one in the US, one here in Europe, and one in APAC, so Asia, Australia, this area. Same thing, time zone, screen resolution, and you need your username and access key. Aside from that, the tests actually look exactly the same. So let's run them, and while they run, we're going to explain a bit more how this works. So things are running there. I'm just going to go to the UI. We can see how the tests are getting executed. And the same features are available. So I'm going to switch here to the Docker UI. And in a gist, it's very similar to the dynamic grid. The difference is that you will have your results in the cloud and you can see them in a single place. So if I go here to the UI, we will see all the tests running. And they get processed very fast because, you know, we have this good machine here locally and I am running tester. So yeah, mostly they are almost done, all of them. So let me switch back this container. Now let's go back to the UI because I think we can now, and what we can see is all these tests, for example, that were executed a moment ago. So let's open one of them. In this case, we see that it's a test on Linux and Chrome 95. So let's check it. And this is a test I was running locally, but it looks like if it was executed in the cloud because all the information looks the same. This is the same data. And you have the commands for each one of running during the test. And obviously you have, for example, the screenshot that is related to that test. If you want to have more detailed debugging capabilities, you have the logs of all the tests, the capabilities that were used, the Selenium server log, and all the metadata related to it. And you can do cool things. For example, maybe this is a bug, so you can click here in our Jira integration, so you can run a test in your infrastructure and then report everything to Jira right away with integrations like this. And then obviously you can use all the insights to obviously check how your tests that were running in your infrastructure are behaving and this and that. You can also say, okay, this test can only be seen by this or that team, and having in mind that, you know, all these tests were running in your infrastructure. So there you go, all tests were running successfully, and that was the demo. Let's move. So as I said, this is an experiment. We want to see what people think about it. So if you want, and if you can, please help me to spread the word. I just want to get feedback to see if this is something that makes sense for people so we can invest more on it, or maybe this is not a good idea. So the idea is that you can combine what you have locally with the cloud. And to recap, basically, we think that the new grid is a drop-in replacement with a few little changes in the configuration. But if not, reach out to us. And if you're using Docker images, as I mentioned a moment ago, please check the Docker Selenium images. And if you have some customizations in your existing grid, also reach out to us, but then as a starting point, use the relay configuration to move slowly. And in the end, this is the URL that you can all go to, where you can see all the links to get into the Slack channel, IRC, and how you can reach out to us. So basically, we can make the community bigger and stronger. And that's what I had for you today. And I really apologize taking a bit more time than what was planned.
No worries. Thank you very much. I don't know if, first of all, it was great presentation. I don't know if there are any questions. I know that Stelios has asked something.
Yeah, I have posted one, the Edwards, you want to have, or I can ask you directly. So when you were talking about having the videos being recorded directly with Docker containers, I was thinking if you have a solution or plan to have a solution to do something similar with Helm charts. So deploy everything with Helm charts. That's the first part of the question. And if you do, if you see any value to have something similar in Kubernetes operators, for example.
Yeah. One of the purposes was to leave the code in a state that can be extended or can be reused to have it in different environments. So we have a template for Kubernetes that is okay. It's not really that good. I mean, it works, but it could be much nicer. But the idea is to have a chart. And the thing is that we're pushing for the release, the 4.0 release, and there is someone who wants to provide a chart. However, maybe they are not around. I don't know why. But in short, the answer is yes. We want to provide a chart that can be used for this. And in the end, to use this video feature in Kubernetes, maybe what has to be done there is to have a pod where both containers are running in the same pod, because it would be a bit more complex. So the way it works right now is that you have a browser where you have a container where the browser is running, and then the video container connects to the VNC that is running, so to record the stream. And maybe having two separate pods for that will be a bit too complex for the deployments and to scale up and all this. So maybe it's just easier to have deployments where you have the two containers in the same pod. And the answer about auto scaling, we were thinking about doing it with code, like talking directly to the Kubernetes API, but that brings a lot of complexity and maintenance costs. So actually someone suggested a more native Kubernetes solution, which is using a function to auto scale. So you can actually ask the grid how many sessions are in the queue, and based on that, create more pods. So I think that's the option we're going to explore. But we don't have anything ready working out of the box because we were focusing on getting the release out.
Okay, thank you. Thank you very much for the answer. Anyone else, guys? Questions? Now it's your time.
Yeah, I think that I wanted to ask about the source to go. What kind of analytics, first of all, are provided? And the second question is that it looks like having a test report in the cloud. So at some point we might be interested into having a description of the test case, and maybe we would need to have something like test steps. I know that we have used, for example, Allure, and Allure provides a library which can upload some let's say, test steps, and you could have it in your final report. So I don't know how you say this.
Yeah. To be honest, one of the main ideas is that there is a large amount of customers that run some tests locally to get fast feedback, but then other platforms, like they don't have maybe laptops with Mac OS sitting just there to run tests, no? Or maybe they don't have mobile devices, so they make this combination of running a few things locally to get fast feedback, but then all the other stuff. So there is like a large group of data completely separated. So the idea is to allow people, okay, I mean, if you like to run tests locally, do it. You can use this, and then you can have all your tests in the single place. So about the analytics, you can have things like this test. It's kind of similar what you had with this reporter in Jenkins that was telling you this test in the last 10 executions is getting slower or is failing, I don't know, half the time, or these are the comments that are getting slower. These are all the analytics that can be analyzed based on the results. And what platforms are you using? What versions of browsers are you using in your latest tests? Things like that that you can get in a dashboard. About the annotation steps, there is a way to do it right now, but basically it's because you say, okay, right now, so you do like, you run your comments, and then you say in a JavaScript execution with Selenium, you say, this is a new step. So you mark it through the code, and I don't know if that's ideal or not, but there is a way to do it. However, the point of this experiment is to gather feedback and see if people think that this is making sense or not. So we haven't really spent a lot of time thinking how the UI could look nicer.
Yeah, I think that it can be useful because one of the things that I have seen is that, okay, having Jenkins, we could easily upload the report and publish the HTML reports. But with other CI/CD like GitLab CI, for example, it's not that easy to go and publish the report. You would need to have the feature of GitLab pages, but it allows you only to have, because it's a static website, so it allows you just to have the latest report, or maybe there you would need to go to a cloud infrastructure and do a lot of manual tests and manual steps, and so it's not easy to have a report uploaded with your screenshot or your videos. So with these CI/CD solutions, I think that this is going to be something very useful, and that's what we needed actually at some point. So that's why we went to a solution like this.
Yeah, that's one of the reasons where you can have projects that record video for you or take screenshots, but where do you put the videos and where do you put the files? So that's one of the problems that I have seen while working in open source. And then you can build dashboards and you can show the videos, but what do you do with the storage? Like where do you put all that? And that's like the first problem that you want to solve. But then the next problem is you are running hundreds of tests every day, but then you would like to understand what information is coming out of it. And that's why we think that this analytics stuff and like diagnosis and all these things could help. Basically because at least in Sourcelabs, we always wanted people to run tests in our cloud, no? Like that was the business model. But right now that cannot be the business model all the time, because you can run tests in your infrastructure and be faster. So why would you use the cloud? So I think there has to be an even scenario where sometimes people want to run tests fast in their first iterations. And maybe when you want to do the pull request and do the merge, maybe you use a few more browsers in the cloud because it's a bit slower due to the latency. Or maybe when you do a release and you put it to production, maybe you run a few more tests. So basically the idea is to experiment and see if people think that this is a good idea or not. Yeah, that's the whole idea behind it.
Great. Is there any other question?
Probably not. Thank you very much, Diego, for this. It was a great contribution for the sixth chapter S.E.T meeting. I think we can end the live streaming now. So again, thank you, Diego. Thank for the guys that attended as well. It was really, really, really nice.
Thank you for inviting.